This marks a significant moment in humanity's journey as we embark on our first mission to orbit Mercury, the planet at the front of our solar system. Despite its small size and initial appearance as insignificant, Mercury is shrouded in a fascinating veil of mystery and intrigue. Recent discoveries, driven by NASA's relentless efforts, have uncovered remarkable secrets about this enigmatic world, sending shockwaves through the scientific community. It stands as a testament to human curiosity and creativity that we are beginning to unveil the secrets of Mercury, a planet often overshadowed by its larger, more colorful neighbors like Jupiter and Mars. Mercury, positioned closest to the scorching embrace of the Sun, with its diminutive size and blistering speed, presents a celestial enigma that merits closer examination. Despite its proximity to Earth, Mercury remains a tantalizing puzzle, its mysteries veiled by the overwhelming brilliance of our solar system's central star. The quest to understand Mercury has been long and arduous, stretching back to ancient times when early astronomers first cast their gaze at the night sky. From the earliest recorded observations in 265 BC to the groundbreaking efforts of astronomers like Johannes Hevelius in the 1600s, humanity's fascination with Mercury has endured across centuries. However, it wasn't until the dawn of the space age in the 1960s that we truly began to unravel the secrets of this elusive planet. The advent of space exploration, spearheaded by organizations like NASA, has provided us with unprecedented insights into the nature of Mercury. Using cutting-edge telescopes and space probes, we have witnessed the awe-inspiring beauty and complexity of this celestial body, revealing a world teeming with hidden truths waiting to be uncovered. Yet, the path to understanding Mercury is fraught with challenges. Its proximity to the Sun presents formidable obstacles for observation and exploration, with the extreme heat and gravitational forces generated by the Sun creating an inhospitable environment for spacecraft. Only through meticulous planning and technological advancement have we managed to launch missions like Mariner 10 and Messenger, which have brought us closer to unraveling the mysteries of Mercury. These bold spacecraft have overcome the dangers of space, offering us a glimpse into the mysterious world of our solar system's innermost planet. The discoveries made by these missions have been nothing short of astonishing, challenging our preconceived notions of Mercury and its place in the universe. From its blistering speed as the fastest orbiting planet to the tantalizing possibility of extraterrestrial life beneath its surface, Mercury continues to captivate and mystify scientists and astronomers alike. As we stand on the threshold of a new era of exploration, driven by the pursuit of discovery and the thirst for knowledge, the scientific community is on the verge of revealing Mercury's most elusive secrets once and for all. The journey to unlocking Mercury's mysteries has been a long and difficult one, but thanks to the contributions of NASA, we are closer than ever to understanding this enigmatic world. The Mariner 10 spacecraft, which conducted 3 flybys, provided the first detailed images of Mercury, revealing a surface pocked with craters and ridges, reminiscent of our Moon. These stunning images shattered previous expectations, showing a world far more tumultuous than scientists had anticipated. In addition to its rugged planetary surface, Mariner 10 also detected a weak magnetic field and an unusually large core, which raised further questions about Mercury's composition. Mariner 10 captured more than 2,700 images of Mercury, offering scientists a unique and unparalleled view of the planet's fascinating landscape. Its second flyby in September 1974 captured the southern polar region, while the final flyby in March 1975 marked the end of its mission as it exhausted its fuel and could no longer communicate with Earth. However, the groundbreaking work of Mariner 10 laid the foundation for future exploration, with NASA's Messenger mission picking up where it left off 30 years later. Unlike its predecessor, Messenger didn't just conduct flybys but actually entered orbit around Mercury, allowing scientists to gather more detailed and comprehensive data. During its mission, Messenger took over 200,000 photographs of the planet, providing an unprecedented look at both its light and dark sides. By analyzing these images and comparing them with data from the spacecraft's instruments, NASA was able to uncover fascinating details about Mercury's surface and interior. One of the most surprising findings was the high concentrations of calcium and magnesium on the planet's night side, which suggested that Mercury's surface might be more chemically complex than previously thought. Messenger also revealed that Mercury's magnetic field is unusually distorted, stronger and more intense in the northern regions of the planet. This magnetic anomaly baffled scientists for years until further investigation uncovered the surprising reason behind it. Mercury's core, composed of a vast amount of liquid iron, generates the planet's magnetic field in a way unlike any other planet in our solar system. This discovery challenged long-held theories about planetary magnetism and sent shockwaves through the scientific community. Mercury's extreme temperatures are another defining feature. Due to its lack of a significant atmosphere to retain heat, the planet experiences dramatic temperature fluctuations throughout its day, which lasts about 176 Earth days. Temperatures can soar to over 430 degrees Celsius (800 degrees Fahrenheit) on the day side, while the night side plummets to -70 degrees Celsius (-280 degrees Fahrenheit). This stark contrast is a result of Mercury's proximity to the Sun, where it absorbs immense solar radiation, yet lacks the atmospheric protection that Earth enjoys. These extreme temperature differentials make Mercury one of the most thermally variable bodies in the solar system. The planet's exosphere, an extremely thin layer of gases, is another intriguing aspect of Mercury. Composed primarily of oxygen, sodium, hydrogen, helium, and potassium, this exosphere is constantly replenished by solar winds and meteoroid impacts. Unlike Earth, which has a thick atmosphere that helps regulate temperature and supports life, Mercury's exosphere offers little protection from the Sun's radiation and cosmic rays, contributing to the planet's harsh and inhospitable environment. Despite these challenges, Mercury continues to offer vital clues about the early history of our solar system. Its extreme conditions and unique characteristics make it a planet of great scientific interest. As we continue to study Mercury, we inch ever closer to solving the mysteries of this strange and fascinating world, unlocking the secrets of our solar system's closest neighbor. Mercury's surface is marked by numerous impact craters, much like the Moon, providing a backdrop of ancient impacts dating back to the early formation of the solar system. These craters vary in size and shape, ranging from small bow-shaped depressions to massive bowls stretching hundreds of kilometers. The largest known impact basin on Mercury is the Caloris Basin, which measures approximately 1,550 kilometers, 960 miles, in diameter and was created by a massive collision billions of years ago. In addition to these craters, Mercury's surface features include scarps, cliffs, and volcanic plains. One of the most striking geological features on Mercury is the extensive presence of lobate scarps, bluff-like structures that stretch for hundreds of kilometers and rise up to several kilometers high. These scarps are believed to have formed as Mercury's interior cooled and contracted, causing the planet's outer crust to crack and fold. Volcanic activity also played a role in shaping Mercury's surface, with smooth plains of volcanic basalt surrounding some of the larger impact basins. These volcanic deposits suggest that Mercury was volcanically active early in its history, releasing molten rock onto its surface. The presence of these volcanic features provides valuable insights into Mercury's geological development and the processes that have shaped its rugged terrain. Mercury's magnetic field is another area of scientific interest and mystery. Unlike Earth's global magnetic field, which is generated by a dynamo process in its liquid outer core, Mercury's magnetic field is weaker and generated by a dynamo process in its partially liquid inner core. Interestingly, Mercury's magnetic field is offset from its center and is stronger in the northern hemisphere compared to the southern hemisphere, a phenomenon that scientists are still trying to understand. The origin and evolution of Mercury's magnetic field are closely tied to its internal structure. The planet is primarily composed of silicate rock and has a large iron-rich core that accounts for around 60% of its mass. This dense metallic core is thought to have formed early in Mercury's history when denser material sank toward the center during the formation of the inner solar system. The interaction between the fluid outer core and the solid inner core generates Mercury's magnetic field, which has been studied in detail by space missions like Mariner 10 and Messenger. Launched in 1973, NASA's Mariner 10 mission was the first to capture close-up images and scientific data of Mercury during 3 flybys in 1974 and 1975. Mariner 10 provided detailed pictures of Mercury's surface, revealing its cratered landscape and volcanic plains, and also detected Mercury's magnetic field, giving important insights into the planet's structure and topography. Nearly 3 decades later, NASA's Messenger mission, launched in 2004, became the first spacecraft to orbit Mercury. Messenger mapped the planet's surface, studied its composition, magnetic field, and geological features in great detail. One of its significant discoveries was the presence of water ice in permanently shadowed craters at Mercury's poles. Despite Mercury's proximity to the Sun, the discovery of water ice in these areas was unexpected. Scientists speculate that comets or asteroids may have delivered volatile materials to Mercury, where they were preserved in cold, shadowed regions. The presence of water ice challenges previous assumptions about the distribution of volatile compounds in the inner solar system and provides clues to the planet's history and potential habitability. Future missions, such as the European Space Agency's Bepi-Colombo mission, aim to build on the discoveries made by Mariner 10 and Messenger. Launched in 2018, Bepi-Colombo is a joint mission with the Japan Aerospace Exploration Agency, JAXA, designed to study Mercury's surface, magnetosphere, and internal structure using advanced instruments and technology. The mission includes 2 orbiters, the Mercury Planetary Orbiter, MPO, and the Mercury Magnetospheric Orbiter, MMO, which together will provide a comprehensive investigation of Mercury's environment and development. Bepi-Colombo's scientific goals include mapping Mercury's magnetic field in detail, studying its surface composition and geological features, and analyzing the planet's exosphere and interactions with the solar wind. By combining data from various instruments, Bepi-Colombo aims to uncover new insights into Mercury's formation, evolution, and ongoing processes. Researchers are also keen to explore Mercury's gravitational field and orbital characteristics. Mercury's orbit around the Sun is highly elliptical, completing a revolution in just 88 Earth days. This unusual orbit causes significant variations in its orbital speed and distance from the Sun, leading to gravitational interactions that have influenced its orbital elements over billions of years. Understanding Mercury's orbital elements is crucial for broader questions about planetary formation and evolution in our solar system. Gravitational interactions between Mercury and other planets, especially Venus and Earth, have shaped its orbit and provide valuable information about the early dynamics of the solar system. Studying Mercury's gravitational field and orbital characteristics helps refine models of planetary motion and stability in the inner solar system. In addition to its scientific importance, Mercury also plays a role in the study of exoplanets, planets orbiting stars beyond our solar system. Many exoplanets discovered so far exhibit characteristics similar to Mercury, such as close proximity to their parent stars and extreme temperatures. By studying Mercury as a representative of terrestrial planets in harsh, hot environments, scientists can gain insights into the diversity of planetary systems and the potential for habitability beyond our solar system. Mercury's significance extends beyond its scientific value. It also holds cultural and historical importance. Ancient civilizations observed Mercury's movements across the sky and incorporated them into their myths and traditions. The planet's name comes from the Roman god of commerce, travel, and communication, reflecting its swift movement across the heavens. Mercury continues to captivate scientists with its unique features, from its extreme temperatures and thin atmosphere to its cratered surface and peculiar magnetic field. As future missions like Bepi-Colombo further unravel the mysteries of Mercury, they will pave the way for new discoveries in planetary science and exploration.